Welcome dear students. Today we'll start a new topic from application of derivatives, and the name of the topic is Maxima and Minima. So from your application of derivatives, for me, as for me, I find that this topic is a bit challenging compared to other topics. So you have already learned about other topics as well. So compared to those topics, this topic is going to be a bit challenging in the later sessions. In the first few sessions you'll find it very easy, but in the later sessions it's going to be a bit difficult for you. But here the only thing is you need to understand the concept. So let's see the concepts that we need to learn in this particular topic, that is maxima and minima. So the first topic that we are going to learn is about critical point, which you have in fact learned in the chapter on, or the topic on, increasing and decreasing function. So this is my critical point. So you can make note of it also in your notebook. So consider this graph. Now so just look at these tangents. Now since we are doing application of derivatives, and all of you know that a derivative of at a point represents the slope of the tangent at that point, isn't it? Now kindly look at this. Look at this line. Look at this line. And look at this line. So these tangents are parallel to x-axis, isn't it? And the slope of x-axis is always equals to 0. So that means the slope of these lines are also 0. M equals to 0. M equals to 0 for all these. So basically M stands for what? M stands for dy by dx, isn't it? So dy by dx, or you can call this as f dash of x. So basically both dy by dx or f dash of x, whatever you want to call it. So these are equal to 0 at these points. So basically these points, so this is one point, so let's call this as x1. So this is your another point, so let's call this as x2. And let me call this point to be this point x3. So basically this x1, x2 and x3 are called the critical point. So basically the points at which the derivative is equal to 0. So if y equals to fx is a given function, so let's say that if y equals to fx, this is my function, y equals to fx. So if this is the function, then the point at which f dash of x equals to 0, the point at which f dash of x is equals to 0, then x is called the critical point. So this is the meaning of critical point. Kindly make a note of it. So next thing that we need to understand is about the two test which decides whether a given function has got its maximum or its minimum. So this is called the test that the first test that we are going to learn is called first derivative test. So as the name suggests, we'll be looking at the first order derivative in this case. So let's see what is the way or rule for checking whether a given point is a maximum or minimum. Is a point of maximum or a point of minimum. Let's see how to do that. So first we'll check for point of maximum. Now from the graph you obviously see wherever you see peak, that is the point of maxima. So this is from the graph. So for example, you see we have got peak out here. This is the peak, right? This B is also a peak. So both are maximum. So what am I trying to do is, first before we go to the test, first and foremost what we need to do is we need to consider one interval. So let's consider this interval. I'm just taking a random interval. So let's consider this interval. So this is my interval, let's say A to B. So in this interval in this interval I'm going to check what is happening. Okay, so what you need to do is first and foremost here you know that this point, okay, this point, at this point it is maximum in this interval. Okay, so let's call this point to be point x. Okay, now what you do is to the left of this x take one point. Let's take this point. Okay, now at this point you will find what will be the slope. Okay, so slope turns out to be somewhat like this, isn't it? So this is how your tangent is going to look. This is my rough diagram. Okay, now just look at this. What will be the sign of this? Now you see this line, this tangent is making what kind of angle? It's making angle which is less than 90. So whenever angle is less than 90, then the value of tan theta becomes positive, isn't it? So that's why here the slope is f dash of x is positive here. Okay, now to the left you have got a positive slope. Now go to the right of the point. Okay, so at this point let's take this is the point. Okay, now at this point if you draw the tangent, okay, if you draw the tangent, now this time this is making angle which is more than 90 degree. So whenever it is more than 90 degree, tan theta becomes negative. So whenever tan theta is negative, it means that the slope is negative. So what did you observe from here is you observe that f dash of x, okay, changes from positive to negative, as you move from left to right, isn't it? So in such case we say that this x, this point x, then this point x is called point of local maxima. Okay, now why local maxima? We could have said just maxima. Now because we are saying local, because we are just dealing with a small interval. This is the whole function, right? But we are dealing with the small interval, so that's why we are calling it local maxima. Okay, so this is the test, or this is how we check whether a function or whether a point is a point of local maxima or not. This is how we need to check. Alright, I hope this is clear to you. Okay, let me erase this now. So if you see here, I have not made you see, we have just found the first order derivative. F dash of x is first order derivative. Now let's check whether a point is a point of local minima or not. So for that also again I need to construct one interval. So let's talk about this interval. Okay, so in this interval you clearly see that at this point, okay, so again let me call this as a, b, and let me call this as x. Okay, so at this point x, it is minimum, as you can clearly see in this interval. Okay, so again in the same way to the left I am going to take 1 point. Okay, so to the left let me take 1 point. Okay, so at this point to the left, at this point I am going to draw a tangent now. So when you draw a tangent, your tangent looks somewhat like this. Now obviously the slope of this will be f dash of x will be what? F dash of x will be negative in this case. Now let's move to the right then. So when we move to the right, let's say at this point, okay, when you move to the right of this point x, then when you draw the tangent out here, okay, so when you draw a tangent, so it's not perfect, so let me erase this. So when you draw a tangent at this point, this will have the slope f dash of x to be what? F dash of x will be positive in this case. So basically when you move from left to right, if f dash of x changes from negative to positive, then we say that the point x is point of local minima. Is that clear? Okay, so same thing. Okay, sign changes from negative to positive. Sign of what? I hope you are clear. Sign of f dash of x changes from negative to positive, then x is called the point of local minima. From the diagram it is clear that it is a point of local minima. I hope this is clear. So sometimes, okay, so sometimes what happens is in the given interval, suppose let's say that this is the given interval. I'm sorry. So let's say that this is the given interval. Okay, so in this interval, if I ask you to find the point of minima or maxima, you don't see from the graph, you don't see. Okay, so suppose you take this point. Okay, so you take this point. Okay, so this is, let's call this to be A, let me call this to be point B, and now let me call this point to be X. Now if you go to the left at this point, your sine is going to see, this is how my tangent is going to look. So here this is, the slope of the tangent will be positive clearly. Now if you go to the right of this point, let's say at this point, and draw the tangent at this point also, f dash of x is positive, isn't it? So is there any change in the sign? No, right? So such kind of point is known as point of inflection. Very important. Okay, so if the sign of f dash of x do not change, then x is called point of inflection. Okay, sometimes you know, they have got two different spelling, so sometimes they will write inflect this way also. Okay, so this is the first test for checking whether the function is having maximum or minimum. Okay, but you know, this process is a quite lengthy process, so we have got one more simple process. Okay, and we call that process as second derivative test. We'll learn about that, but if you want to make a note of it, you can make a note of it quickly. Right, so let's see the second derivative test. Okay, so this is my second, you know, method for finding the maximum and minimum of a function. So second derivative test. So let's have a look at this now. Second order, see, as the name suggests, we need to find second order derivative of the given function. Okay, so as you all are quite aware that this is y equals to fx. Okay, so here I don't have anything to explain, so here I just need to tell you one thing. So first you find, okay, find critical points. Okay, critical point or points. Next, what you do is you find f dash of x. Okay, obviously you find f by f dash of x equals to 0. Okay, so obviously you find critical point using the first order derivative only. All of you know this. Then after that, find f double dash of x, second order derivative. Now it says if f dash of x is I'm sorry, if double dash of x is positive, okay, then x is a point of minima. Kindly make a note of it. When it is positive, when second order derivative is positive, then x is a point of minima. Now number 4, if f double dash of x is less than 0, then x is a point of maxima. Kindly make a note of it. Okay, so that's all about your you know, second order derivative test. Now sometimes what happens is, okay, so this is my fifth point, if f double dash of x is also 0, then it is not satisfying this point and this point. No, so that time you have to go to first derivative test. I hope this is clear to you. Okay, and one more thing I forgot to tell you. So I told you that this is a point of inflection, isn't it? So whenever you get that there is no change in the sign from sign of you know, from left, when you move from left to right, if there is no change in the sign of f dash of x, then that point is called point of inflection, and at that point there exists no maximum and there exists no minimum. That's what you need to keep in mind. Okay, right. So next very important part is, now as I said, this is also maximum, this is also maximum, isn't it? So this is maximum of all the maximum out here, isn't it? So this is called the highest point, or the one which is having the maximum value. That is called absolute, or sometimes we call it global maximum. Okay, now here this is also minimum, this is also minimum. Okay, so this is called, this is the minimum. Okay, minimum of among these two is this one, point A. So this is called absolute or global minimum. I hope this is clear to you. You have to keep this thing in mind. Okay, right. So is there anything left? No, that's all. Okay, so kindly make a note of it, and in the next class we'll be learning about, or we'll see some problems based on maxima and minima, right? So thank you for watching.